Okay, now on to section 4 for the CS 113 final review. So for section 4, what we did is we have a graph here, a directed graph with values, and basically we want to find the shortest path from node A. So we're going to find the shortest path from node A to every other node. And let's go over that and kind of see what it would look like. So here's our graph. Let me shrink that out a little. Okay, so what we do is we have our sets of V and Vs. Initially, set V will not have these additional values over here in it, but it will have all the rest of the values, so B, C, D, E, F, G, and G. So here, initially we start out with going from, here's all our vertexes, B, C, D, E, F, G, and H. Again, A is not in this since we're starting from A. Our dV initially starts out as infinity for all the values. And our PV starts out as position A for all the values. So one thing just looking at this graph that you'll notice is that vertex D can never be reached in our graph. So because of that, when we are trying to find the shortest path from A to D, essentially there is no shortest path from A to D, and that's denoted by our infinity since we can't reach it. And so there is no path from A to D, and that's infinite. Anyways, if we run our algorithm, we look at our values from A and look at the other two. So we would write 10 going to B, and that came from A. And we would write 60 in C, and that came from A. And we would see that our shortest value now is, because we're going to take a greedy approach to this, Dijkstra's greedy, as from the last class, we pick value 10, or we take this path, which is the lowest value here. So we now look at everything from vertex B. So we move B from VS up into V, and now A and B are done. So now we look at all the values coming off of B. So B to F would be 80. B to H would be 30. If we look at 30. Next, B out to C would be 40. 40 is now less than 60, so we cross out 60 and write 40, and that came from B. So at our second step, we have C at 40, H at 30, and F at 80. The next smallest value from our graph would be H, so that because that's the 30, so we would start at H, and that came from B. So 30 now, we're done with H, and that's would go up to here from V to VS. Now we look at all the values from H. H only goes out to G. G is currently infinity, and that's 90, so we write 90 down here, H here, and now we look at the smallest values of for the tree. As you can recall, we wrote 40 into C, so C would be the next value that we write here. So C would be our next value that we look off from H. So C gets pulled up from VS to V, and then we look at all the things from C. C only points back out to A and to E. E is going to be 45 because it cost us 40 to get to C plus 5 more to go to E. And we don't care about A since we start from A. So E gets 45, and that comes from C. We're done with vertex C. Next we look at our next value, and the next lowest value is E, and that's 45. So 45, it would cost us an additional 45 to go to G, which happens to be the same amount that was already in G through H, so we don't write that. And we can also go to H, but we can't but that's already been done, and that's in our V, so there's nothing else to do here. So we're done with E. The next lowest value in our column is, I guess, F. Oh, I forgot to do F on the initial walkthrough. So when we went from A to B to H, I missed this, where H going up to F, it was originally 80 going across this top route here from A to B to F, but it's only 45 when we go from A to B to H to F. So that gets changed from 80 to 45, and we say we go through column H, and F is the next guy we look at. F doesn't have anywhere he goes to, so we're essentially done with F. Finally, our last value that we look at is the next lowest value is only D and G at this point in time. So G is less than infinity, so 90 is less than infinity, so we use G. So G is now picked. G only goes up to F. F is already in our set of V, so we don't need to worry about F, and we just simply are now done with G, and that gets added up to V. We're still left with D, but again, nothing goes to D, so we're left with our visited set of A, B, H, C, E, F, and G, and our VS still has D, but there's nothing that goes to it. And then here's our final table that we have for Dijkstra's. So if, for example, we asked what's the shortest path to F, we could go back and figure that out. So to find the shortest path from, for example, A to F, we would basically have to go through H, which would have to go through B, which would go through A. So we would say the shortest path from A to F is A, B, H, and F with a cost of 45 to go from A to F.